Okay, we are looking at question number 15, and this video will cover all the problems on page 3 of the probability test review and also page 4. So we are looking at this diagram, and so I want you to ignore all of the text that's up here because it was just a mistake that we made in putting this here. This actually goes to a different problem. So we want you to focus on this diagram and this question right here, okay? So first, let's look at the diagram. We have a randomly selected teenager here, and then 0.93 is the probability that that randomly selected teenager is online. Because you see we have online with a Y, which means yes, and here we have online with an N, which means no. So this segment represents a randomly selected teenager who is yes online, 93%. Then that means that there is a 7% probability that we have a randomly selected teenager that is not online, which is the leading to the N, which means no. All right, now if we go back up this way, 0.55 means that if we know the student is online, yes, then there's a 55% chance that that student also has an online profile. So that's yes, followed by another yes. All right, then if we multiply 0.93 times 0.55, multiplying these two together, we get this value here, which is 0.5115. So that would be the probability that a randomly selected student is online, yes, and has an online profile, yes. All right. Then we can go from this segment to this segment, which is, this segment is given that the student is online, there's a 45% chance that the student does not have a profile, which is why we have the letter N here. So if we go 0.93 times 0.45, we get this number, which is 0.4185, and that is the probability that a student is online and does not have a profile. So that's 0.4185. Then if we go down here, this 0, that comes from multiplying this segment times that segment. So that's 0.07 multiplied by 0. Now, that's 0 because if this segment means that this randomly selected student is not online, and if that student is not online, then that student would not have an online profile. So that probability would be 0. So that's 0.07 times 0 is 0. So this is the probability that a student is not online and has a online profile. That would be 0%. Finally, we have this segment multiplied by this segment, and this segment is the probability that given a student's not online, the probability of the student not having a profile would be 100%, or 1. So now we have 0.07 times 1 is 0.07. And what does that mean? That's the probability that the student is not online and does not have a profile, 0.07. Okay, now let's use this to help us answer the question here, which is what is the probability that a student is not online given that the student does not have a profile? We're going to use this formula that you were given. It's the probability B given A is equal to the probability of A and B divided by the probability of A. So in this case, that would be the probability. Probability A is probability that the student has no profile. So the probability the student does not have a profile would be the sum of this probability, this N, and the probability of that N. So the probability of this n is 0.4185, and the probability of that n is 0.07, because these two numbers represent probabilities with no profile. So what we'll do is we'll add these two numbers together, 0.4185 and 0.07, and we get 0.4885. That is going to be the denominator of this fraction. That's going to be that's the probability of A, 0.4885. Okay, then we need to get the numerator, which is probability A and B, which means probability that the student is not online and does not have a profile. So if we look at the diagram, we're looking for two n's, probability that is not online, that's the first n, and the probability that the student does not have a profile, so that is 0.07 times 1, which is this 0.07. That's going to be our top value. So that's probability not online and no profile is 0.07. Then we just divide this in our calculator, and we get 0.1433, which converts to 14.33%. All right, number 16. So we're going to use this flight information here to answer 16A and 16B. 16A says, what is the probability of a flight being on time given that it occurred in 2013? So what we want to do first is we want to look at, since it's given that it occurred in 2013, we want to look at all of the totals for 2013. So we look at the 2013 column, we go down to the total, and that's 940. So 940 is going to be our total, which is in the denominator. And then in the numerator, we want just those that were on time. So we look at the on-time row and go over to the 2013 column, and we have 750. So that's 750 out of the 940 would be flights on time given that it's in 2013. So we do 750 divided by 940, and we get a percentage of 79.79%. Then to answer B, B says, what is the probability that a flight occurred in 2011 given that it was delayed? So then we have to look at all of the delayed flights first, which is 630. That's going to be in the denominator, 630. And then of the 630, how many were in 2011? So we go to the 2011 column, and there were 200 delayed. So we simply divide 200 by 630, and we get our percentage of 31.75. All right, here we have number 17. It says the school recently conducted a survey to see what courses students are interested in as electives. The table below shows the results. Find the probability of the following as a percentage. So for A, it says the probability that a student likes PE. So what we need to do is find the total PE and divide it by the total students. Well, the total PE is adding the 30 and the 28 and the 31 and the 42, and that gives you 131. The total number of students is adding all of these numbers together. So that's 1, 2, 3, 4, 8, 12, all 16 numbers. And so that would give you 537. So 131 divided by 537 gives you a percentage of 24.39%. Question B says, what's the probability that a student is in the 10th grade given that the student likes technology courses? Well, so on the bottom, we need to find the total of the technology courses. So we add the numbers that are In this purple box, which is the technology line, 21 plus 23 plus 45 plus 47 gives us a total of 136. Now, out of that 136, we only want those in the 10th grade. So then we just go back here and we circle the 23. That's going to be your top number, and 23 divided by 136 gives you 16.91. Okay, now we have problem C. A student likes fine arts. So what's the probability that a student likes fine arts given that the student is in the 10th grade? So since we know that the student's in the 10th grade, that's going to be on the bottom. We need the total number of 10th graders on the bottom. So that is this column here that is enclosed in green. So we'll add the 28, 31, the 23, and the 45 to get that total. That's 127. That's the total number of 10th graders. And then of those 10th graders in this column, we're going to circle the ones that like fine arts. So that would be this number here, which is 31. That's kind of covering it up, but that is a 31 there. And then, so that'll be 31 out of 127, which is a percentage of 24.41. All right, then number 18. It says, given that the probability of A and B is 0.3 and that the probability of A is 0.5, find the probability of B given A. So just reminding you of the formula, the probability of B given A is the probability of A and B divided by the probability of A. So then we would just substitute the values that were given. So probability A and B was given to be 0.3. That goes on the top. Probability of A was given to be 0.5. That will go in the denominator. Then we just divide 0.3 by 0.5, and we get a probability of 60%. And then number 19. So if the probability of cars given males is 0.24 and the probability of males is 0.57, find the probability of cars and males. All right, so just to remind you, so this follows the format of this equation here. Probability A and B is equal to probability B times the probability of A given B. And we know that the probability of B was given. Probability B is males, probability males, which is the 0.57. And then probability A given B is right here, probability cars given males. That was 0.24. So we'll multiply 0.57 times 0.24, and that results in 13.68%.